If you've never done baked lighting, light map UVs may be new to you. Generally, when doing architectural visualization, you create material UVs and then essentially hit render. All the lighting information is rendered into the 2D image or video you create. You may even render out separate passes with directional lights, ambient lights, shadows in their own images and whatnot, and then combine those later by compositing. Now, baked lighting is done in a similar fashion for real-time walkthroughs, but in order for baked lighting to be created, you first need to generate light map UVs. Light map UVs work identically to material UVs. They're just used for lighting information instead of material information, allowing for a very high-quality global illumination scene to render in real time. GPUs are still not powerful enough to handle true GI quality at real time using dynamic lighting. That's why we use baked light maps. Unreal Studio supports both dynamic and static lighting. Now the difference is dynamic lighting is a light that can have objects move past it or through it, and they will project shadows and be affected by the light, and the light itself can move as well. Now this is great for real-time simulations that involve a lot of moving parts and characters moving through, and it does project shadows and everything, assuming of course that cast shadows is checked, like my sunlight here. But it can be very expensive because it's having to calculate these shadows and lighting at runtime every tick, which could be 60 frames a second, it could be 90 frames a second in the case of VR, or whatever the case may be. Now the other option would be static lighting. So I can set my light to either stationary or static. And when you put it to static, it means that the light will be fully baked. There will be no dynamicness to it. The shadows won't be dynamic. The light can't move. And anyone that would move through it, if you had a character move through it, they would not project dynamic shadows. Everything is baked into the light map. Now, the good thing about static lighting is it doesn't have to be calculated the same way as dynamic lighting at runtime, so you save a lot on performance. However, the negative side of it is that it does take up more memory because you're having to bake the light maps, which obviously take up space in the video card's memory. Now, the benefit that static or baked lighting has over dynamic lighting is that just like with your renderer in 3ds Max or Maya or Blender, say V-Ray, you're going to be able to get that high quality lighting, so you're going to get global illumination lighting with bounces and color bleed and all of that. Now, obviously right now it says preview on my meshes here in Unreal. That means I need to bake my lighting because currently my sunlight is, we set it to movable or dynamic, and that cleared out the lighting, the baked lighting, and then we set it to static. So now we need to rebake the lighting. Also up here, it would tell you normally that lighting needs to be baked, but I have my stats turned off. Turning that on, we can see we've got a red message here reminding us that we do need to bake our lighting. The good news is creating light map UVs can be as easy as pressing a button. As we saw earlier, the Unreal Studio import options allow you to automatically generate light map UVs. Unreal does a fantastic job of creating non-overlapping light map UVs that generate great results. Now, if you need greater detail in the light map for a given object, you can easily adjust the light map size both on import as well as later on in the asset's settings, or even on a per instance basis in the instance properties for a given mesh in the scene. Alternatively, you can create your own custom light map UVs in your 3D tool. This is sometimes necessary when working with very complex organic shapes, such as curtains, covers, or in the case of the couch here, these pillows. Alright, so we have the light map UVs up for the couch here, and there's a few problems that we need to solve. First of all, light map UVs cannot overlap. Now when you're doing projection mapping for diffuse textures, obviously you can overlap your UVs, that's not a problem usually. But when you're doing light mapping UVs, when the lighting is going to be baked in Unreal, none of these UVs can overlap. They have to all have unique coordinates. So what we need to do is just pack these UVs so that they no longer overlap. Now any 3D tool is going to have packing tools. So if we go in 3ds Max here, we've got our pack UVs tool. And one thing we want to also make sure is that we set our padding. At least a value of 0.01 is generally what I use. You could use as high as 0.04 possibly. The point is you want to make sure that these UVs are not too close together to the edge or themselves, because that will cause light map bleed. So you'll see perhaps black where it should be white and vice versa. So I'm going to leave this at 0.01. All right, and so there are our unpacked UVs, nice and clean, not overlapping anymore, and we've got good padding between them. And that's going to help avoid light map bleed. Now, another thing we want to do is fix any bad seams we have in our light map UVs. Just like with diffuse textures UVs, you don't want to have seams in obvious places.
It will be especially noticeable with light maps. There will be noticeable seams in the lighting, harsh lines and whatnot, especially where the shadow meets the light. But obviously we'd need to come in here with seaming tools and basically weld these seams together in such a way that the front face of the pillow here is a single shell, and then, maybe it's broken along the sides of the pillow, and then the back is a single shell as well. And that way you're going to avoid any light map seams. So over here in Unreal Studio, we've got the static mesh editor open. We'll go ahead and show the UV channels for channel 0. This is the projection mapping for the diffuse texture. And then we have channel 2 down here. This is our light map UV channel. Bear in mind the channels in Unreal are 0 based, so this channel 0 corresponds to channel 1 in 3ds Max. Channel 2 is our light map channel, and then over here on the right under details, under general settings, you'll find light map coordinate index, and this is where you can specify which UV coordinates you want to use, which channel. And so obviously we have it set for channel 2 to match up with our light map UVs. Now once your light map UVs are set up, making your scene lighting is a simple process using Unreal's light mask rendering system. If you want to learn more about using Unreal's light mask for creating stunning global illumination lighting in your scenes, be sure to check out the wiki as well as the learning videos on light masks. Up next, we'll cover working with clean geometry to ensure the best performance and visual fidelity in your real-time scene.